So you're on page 79 in your textbooks. We're doing lesson 2.3. We are talking about applying deductive reasoning. You should have already written your vocab. Can somebody tell me what deductive reasoning means?
It uses facts, definitions, accepted properties, and laws of logic for a logical argument.
Very good. I like the last part of that the best. It uses laws of logic to form a logical argument. Deductive is when you're looking at information and you deduce something. You take something out of whatever you're looking at. Okay? So the key concept, let me take a picture and put it in here. Oh, gotta turn it over. Hey, there's you guys. Sorry. It's not on the video. Whenever I do this, it pauses. I think. Guess you'll find out. All right, so here is the key concept that we're going to go over. The law of detachment. If the hypothesis of a true conditional statement is true, then the conclusion is also true. So let's look at this law of syllogism. This is something you need to have in your journals because I don't expect you to memorize this. You can use this on your test. If the hypothesis P, then conclusion Q, and then you find the if hypothesis Q, then conclusion R. I don't know, I need my pen. Then if hypothesis P, then conclusion R. You see how if this equals this, and this equals this, you can finalize it by skipping saying this equals this. Does that follow? It'll make more sense once we throw numbers in here. Right now it's kind of confusing. All right, so let's go to one. Look at example 1. Let's put this in your journals. Use the law of detachment to make a valid conclusion in the true situation. So, let me... So for A here, we have if two segments have the same length, then they are congruent. It tells you, you know that BC equals XY. Okay, so this is our statement. Try not to look at the solution here, just look up at the screen. So using the law of detachment, let's make another conclusion about this. So if two segments have the same length, then they are congruent. And we know that BC equals XY. This is a straight up equal sign. So we can change that using the phrase you just read. What's the phrase we just read? I think I can highlight it. You see how this says equals? That's what we can change. We can say that, whoops, wrong pen. BC, the segment, is congruent to XY. That's a terrible Y. Okay, let's do another one. Mary goes to movies every Friday and Saturday night. Today is, this one's a little easier for you to, I think. Today is Friday. All right, so Mary goes to the movies every Friday and Saturday night. Today is Friday. So what do we know is going on?
Mary's going to the movies.
Yep. So you would say, today is Friday. Mary is going to the movies. So we took, this one's a little bit better to look at. We took what it says here. We know that she goes every Friday and Saturday, and that today is Friday. So we were able to deduce or conclude that Mary will be at the movies tonight. Any questions so far? This is mostly what you're going to be doing. Okay, so now let's use the law of syllogism. I don't know if I'm saying that right. That's always a weird word. So if possible, so when you hear if possible, that means it is possible for it not to be possible. Use the law to write a new conditional statement that follows from the pair of true statements. And I'm going to take a picture of this because typing it takes too long. All right, so we're going to look at each of these. Use my highlighter. So for A, if Rick takes chemistry this year, then Jesse will be Rick's lab partner. If Jesse is Rick's lab partner, then Rick will get an A in chemistry. So let's look at what we have here. If Rick takes chemistry, then Jesse will be Rick's lab partner. If Jesse is Rick's lab partner, sorry, I'm mumbling here, then Rick will get an A. So when you're looking at this, you can cut out the middleman, which is the green. So we can actually say, if Rick takes chemistry this year, then what can I deduce? Then Rick will get an A. In chemistry. So you see how I did that? And then when you're doing your lesson, don't be afraid to highlight stuff like I did, or underline, or cross out, whatever works for you. All right, so let's look at this next one. I think the picture's there, so. Huh, guess not. All right, so let's look at B. I'm going to use my highlighter again. If x squared is greater than 25, then x squared is greater than 20. If x is greater than 5, then x squared is greater than 25. What do you notice is the same?
X squared is bigger than 25.
Right. The hypothesis and the conclusion are the same. You see that? So then we can conclude that if x is greater than 5, then x is greater than 20. X squared greater than 20. Is this starting to sink in? I know it's a little tricky. Charlie understands it, so we're good. Since he's in this class. Good. Okay, so let's look at the last one. If a polygon is regular, whoops, not, I want to do the highlight. If a polygon is regular, then all angles in the interior of the polygon are congruent. If a polygon is regular, then all of its sides are congruent. So what are the two statements that are true?
All the angles in the interior polygon are congruent.
Well, let's look and see what's true here. These are what out of the sentence? Hypothesis or conclusion? They're both the hypothesis, absolutely. You can't have both be the hypothesis or both be the conclusion being the same. So in this case, there's no, you can't do it. There's no solution. Because they're both on the same end of this. See how these were opposite? Same with the ones up above, they were opposite. One's a conclusion, one's a hypothesis. So if they're both hypothesis or both conclusion, you're not going to be able to solve it. Okay? Any questions on that?
So you have 15.
All right, so let's look at example 3. Woo, I spinned upside down. Try and whisper, Ben. What conclusion can you make about the product of an even integer and any other integers? So we're going to look for a pattern in some examples. So they have the product of an even integer and any other integers. So if I have -2 times 2, I get -4. If I have -1 times 2, I get -2. If I get 2 times 2, I get 4. If I get 3 times 2, I get 6. Have you noticed any pattern yet? What do you notice about all of these? They are, which means they are odd or even? Evens. So anytime you multiply an even integer, you're going to get an even integer, even if you multiply it times an odd or an even. Does that make sense? So we can conclude that the product means multiply, of an even integer and any integer, doesn't matter if it's positive, negative, odd, or even, any integer, the product is what?
Even.
Yep, is an even integer. Make sense? This was example 3. All right. Let's look at example 4. We're going to decide whether it's inductive or deductive reasoning. So, for A, it says, is it time to go? Come in quietly, I'm still teaching. Okay. Okay, so for A, it says, each time Monica kicks up a ball in the air, it returns to the ground. So the next time Monica kicks a ball up into the air, it will return to the ground. Did she use inductive or deductive reasoning? She's doing an action over and over again like we just did. We just checked on the even and odd integers. So we looked for a pattern. Whenever you look for a pattern, it's considered inductive reasoning. Okay, so for A, it's inductive reasoning. B, all reptiles are cold-blooded. Parrots are not cold-blooded. Sue's pet parrot is not a reptile. So this is not a pattern, it's a fact, right? So we used a hypothesis and the conclusion, used that conclusion to form a new hypothesis to give me a new conclusion. So that's what you do when you find deductive reasoning. Okay? All right, so you're going to do numbers 4 through 14. All.